Bring 'em out, hey. Bring 'em out, bring 'em out, you. Bring 'em out, hey. Bring 'em out.
Hey guys, Shig Dog here. Shout out to all my Shig pups. Y'all ready to do this quadratic review? I'm starting the review on number 7, because you should have already done 1 through 6 in class with your teacher. So this is over quadratics for your test tomorrow, Wednesday. So part of your test is going to give you 3 equations. We can compare these 3 equations by plugging them in our calculator. Okay, so the first equation we have is 3x squared minus 6. The next equation is 1/3 x squared plus 8. And then we have negative 1/3 x squared plus 9. Okay, so if I graph them, I can see my 3 different equations.
Pardon the interruption. Derek Pink, if you're in the building, please report to the assistant principal's office. Derek Pink to the AP office. Thank you.
So they want us to circle which ones are the same for all 3 equations. So the first part's looking at our vertex. You can see that here the vertex is at 0, it looks like 8. Here it's at 0, 9. And here it's at 0, negative 6. Those vertices are not in the same place, so these are not the same for all of our equations. Now, the axis of symmetry is the line that cuts it in half. So for every single one of these, the line that would cut it in half would be x equals 0, or the y-axis. So the axis of symmetry is the same for all of those equations. Okay, domain. Domain is the same for every single quadratic unless it has endpoints. None of these have endpoints, so it's all real numbers. So it's the same for all of them. Okay, so range is talking y values, which is bottom to top. So for this black graph right here, we don't know where the bottom's at. But for the blue graph, we know where the bottom's at, and it's a different place than the red one. So the range cannot be the same for all of those. Okay, minimum. The red and the blue have a minimum, so 2 of them do. But not all of them are the same. One of them, this black graph, has a maximum. So one of them has a maximum. Okay, zeros, roots, and X intercepts. Math rocks. Roots, zeros, X intercepts all mean the same thing. And when I'm looking at this graph, you can see there's X intercepts here and here, here and here, and this one doesn't even have X intercepts. So they are not the same for all of them. Okay, the y-intercept. For these graphs, the y-intercepts happen to be the vertices. It's where it crosses the y-axis. All 3 of these are crossing at different points, so they are not the same. Coefficients. Coefficient is the number in front of the variable. So here it's a 1/3, a 1/3, and a 3. So the coefficients are not the same in all of them. Okay, for number 8, identify the following from the function. Okay, you can do it from the equation, but I'm a visual person. So I'm going to go on my calculator, and I'm going to type in the equation. Clear all these out. So we have parentheses, x plus 2, close parentheses squared, minus 5. Okay, so if I go and I look at my graph, I can easily see that that is a minimum. It is a minimum because it's the lowest point. Okay, it's opening up. Which way are the arrows pointing if I was to draw arrows on them? It's opening up. Okay, the vertex. We know the vertex is at -2 something, or around in there, but it's hard to see. So I'm going to go to my table, second graph, and we're looking for our pairs to find the vertex. So 4 goes with 4, -1 with -1, -4 with -4, and right in the middle is -2, -5. That is our vertex. Axis of symmetry comes from the vertex, and it always starts with x equals. The x value of our vertex is -2. So this comes from the vertex. All right, number 9. Given the equation g of x equals 2x squared minus 9, write the new equation in standard form if it is shifted up 6 units. Okay, to make it go up, we're affecting the c, or the y-intercept. So standard form is y equals ax squared plus bx plus c. So to make it go up, we're changing the c value, which is the negative 9. To go up 6, you add 6. So I'm going to come to this equation, g of x equals 2x squared minus 9, and I'm going to add 6 to this negative 9. So my new equation, you can call it whatever you want to, I'm going to call it h of x, is 2x squared, negative 9 plus 6 is a negative 3. That is your new equation. Okay? B, using g of x, so we're using this original g of x equals 2x squared minus 9. We're going to multiply the coefficient by 2. Okay, you have to know the definition of a coefficient. It's the coworker to x, or this number right in front of the variable. So we're going to multiply it times 2. So our new equation, again, I'm going to call it h of x. 2 times 2 is 4, x squared minus 9. So we need to decide if the transformation causes a vertical stretch or compression, as well as a horizontal stretch or horizontal compression. I'm a visual person, so I'm going to go on my calculator. We've got 2x squared minus 9 for the original, and 4x squared minus 9 for the new one. Look on my graph. There's the original. There's the new one. So we got skinnier. When it gets skinnier, that is a vertical stretch. To make it get skinnier, you're pulling it out. So to pull it out, it's going to make it skinny. Now, if it's a vertical stretch, it is a horizontal compression. These must be opposite. So if you had an answer choice that had both of them as stretches or both of them as compressions, you can eliminate those. One has to be a stretch, one has to be a compression. Again, if you're a visual person and you're talking horizontal, the original is our blue, so it was out here, and we're squishing it in. So side to side wise, we are horizontally compressing it, squishing it. Okay, on to the back. When compared to the parent function, describe the transformations that occur in each equation provided. Guys, you may know what each part does to the equation. Check yourself. Go to your calculator, and we're comparing it to the parent function. Now, the parent function is y equals x squared. So I'm going to graph my original, x squared, and then compare. So that first one has negative parentheses x minus 6 squared. So there's my original, and there's my new one. Well, right off the bat, I can see that it reflected. Okay? Guys, you're comparing the vertices. Here's one vertex, here's the other vertex. It shifted right. Okay, you can tell that from the equation. The negative out front is what caused the reflection. And when you have x minus a number, it's the opposite of what you think. So it's going to the right 6. Perfect. Okay, so let's check the next one. We still have the same parent function. So I'm just going to change the second equation. 2 parentheses x plus 4 squared. Go to my graph. There's the original. There's the new one. All right, you can see that it's narrower. To make it more narrow, that is a vertical stretch. A vertical stretch is the same thing as a horizontal compression. You need to know either one. Okay? It's also shifted left, or translated left. That's it. Looking at the equation, the 2 is the stretch, the vertical stretch, and the plus 2 makes it go left. Plus makes it go left, minus makes it go right. Looking good. All right, last one in this section. Parent function stays the same. And we have parentheses, x plus 3 squared minus 5. Original and the new one. Okay, you can see that the graph was shifted left, and it also went down. I don't think it got fatter or wider, but we can check looking at the A value. Did the A value change? The value out in front? No, there's nothing there, so it stayed the same, talking about how wide or how skinny it is. All right, this last part, the ball is thrown off an 80-foot tall building. Its path is represented by the graph below. Fill in the blanks. The ball was dropped from a height of, okay, technically it wasn't dropped, it was thrown, but its starting height is 80. It was in the air, so here it is, they threw it up, it went down. This point right here represents when it hit the ground. So it was in the air for 6 seconds. And this is the y depends on the x. The y is the dependent variable. Remember, we've got Dr. XY needs his ID to get in and out of the hospital. The dependent variable, the one that's depending, is the y. Okay, so what is the y variable? The y-axis is the height, depends on the x variable, which is time. Okay, so what is the meaning of the x-intercept? Well, we already said it. This right here, what's happening? They're throwing the ball up, and then it's coming down and hitting the ground. So when it hits the ground, because the height is 0. Okay, what does the point 555 represent for the situation? This is the x, this is the y. The x is time, the y is height. So the ball was at a height. Which part was the height? The 55 after 5 seconds. Now there's several ways you could say that. You could say after 5 seconds the ball was at a height of 55. You could say the height of the ball was 55 after 5 seconds. However you want to word it, as long as you have height of 55 and 5 seconds. Okay, so match up your variables to the x and the y axis. Okay, I'm going to ask one extension question. This is for you, Austin. Okay, what is f of x equal to 115? Okay, this 115, is it an x value or a y value? Okay, remember we've got our in, let me show you. Okay, if it's in, see how it's inside my parentheses, it's x. And if it's out, it's a y. So looking back at this problem, okay, is that 115 in or out of the parentheses? It's outside the parentheses, so it's a y. So I'm going to go on my y-axis to 115, which is right here. And it hits right here and right here. So that's happening at 1.5 seconds. And it's also happening, this is kind of hard to tell, maybe 2.75 seconds. So follow it all the way across to see where it's hitting. Now, what if I asked you, what is f of 5.5? So this time it's in the parentheses, so it's the x value. So I'd go on my x-axis to 5.5. It hits it right here. And the y value is 30. So that's that function notation. Make sure you know whether it's giving you the x or the y, and that's the axis you follow it over from. Okay, good luck on your test tomorrow. Don't forget DPM on Friday.